Okay, let's go through the specific examples for this equation to show how it simplifies. As part of any process, you're going to want to start with this entropy balance equation, and then just based on your system as you've drawn it, cross out the different terms. So, for instance, a closed system, what should we do? Closed system, we can still change in time. Closed, set this equal to 0, leaving only the latter two terms. Now what about an adiabatic? Means set q dot equal to 0. Reversible. If you remember my first derivation of entropy, reversible spelling, Sgen equals 0. Now what about my personal favorite, an open and steady system? Not Steisdom, system. What do you do for open and steady? Steady tells you ds dt equals 0. Everything else remains. You'll still have the sum over all your streams, k equals 1 to capital K, mk dot sk hat plus q dot over t plus s gen. You just don't have the derivative. And that is it for now. What you should think about now, what about for a system from A at one time to B at some other time? It will be helpful to have the integrated form. Of entropy balance, also called the difference form. Because, after a certain amount of time, you ask the question, what's the difference? Well, here's the difference. Entropy at some time 2 minus entropy at some state or time or position or whatever, 1 equals the sum over all of your streams, except now you have to worry about how long the streams were flowing. And so you integrate from the time at the beginning to the time at the end of your dynamic stream balance equations. And of course, you're integrating with respect to time as your variable. Plus your heat flows over time, T1 to T2 of Q dot over temperature times dt, plus your Sgen over time 1 to time 2 of your Sgen dot dt. I'll leave it up to you to get the all of the same 1, 2, 3, 4 for the difference form. It's called transfer. Same principles. Closed system, set mk equal to 0. Adiabatic process, you set q dot over t equal to 0. Reversible process, you set Sgen, the integral of the whole thing, equal to 0, and so forth.